The first thing that would be great to know is a little bit about the company and how the technology works. Some of the details of that would be brilliant. So Russ or Tony, I don't know who wants to go first on that.
Russ, take it away.
Yeah, I'll introduce the company. So Menlo Microsystems was a technology that was spun out of GE 4 years ago, or more than 4 years ago, where basically through material science, we've reinvented the electronic switch. And as you know, switches are in virtually everything. The entire background of the company started with GE engineers who were looking to basically reinvent the circuit breaker. If we look at switches and in all of the applications that they're used, whether they're an electromechanical switch, those haven't changed in over 140 years. And basically the transistor was invented 70 years ago. And so we've basically taken the best of both of those things and come up with a device that is far more efficient in switching power and switching electricity, in switching wireless communications as well.
And can you give us an idea of how widespread this could be if this really changed the switching technology? It's not something, I have to confess, that I've ever really thought about before. So that's fascinating that it's, you know, it's in everything and it hasn't been updated for decades. You know,
you can think about it just in your smartphone. There's at least 20 switches that are tuning the antenna to get you better reception. And in a 777, there's hundreds of thousands of switches. In your car, there's tens of thousands of switches. And you start thinking about your home, everywhere from the circuit breaker on the side of the house to all of the light switches to all of the switches that are in every single appliance in your home or in your office. And so all of the energy that we use is distributed through those switches. And so the efficiency of those has a huge impact in how energy is used and how communications is done.
So Alice, let me just chime in here. So just to be clear, in the US last year, over 60% of all the energy generated was lost in inefficiencies. And some of that, and a lot of that, goes through switches. So think about 100% of the energy in the US, it's even bigger worldwide, of course. 60% of it is just being thrown away in inefficiencies from the time it was generated at the power plant or wherever, all the way to the place where we consumed it. And so we talk about getting to green energy and these kinds of things. Well, we could do that, that's great. But how about saving the 60% of inefficiencies we have in the system? Could you imagine if we could go green much more quickly because we only need 40% of green energy and the other 60% is saved? That's the kind of thing, you know, everyone's like, oh, batteries and, you know, solar and wind and all that stuff. People don't look at the systems. They think they work really well. And frankly, they don't. 60% is wasted.
It's so interesting, the psychology of that. I think when VC investors are coming to these kind of climate change things, apparently one of the first things they think of is something consumer related, something that relates to their lifestyle. So they want to invest in electric vehicles because they might have a Tesla, or they might want to invest in Beyond Meat or something, some kind of alternative food because they might have gone vegan. And whereas actually energy efficiency is such a massive problem, but it sort of doesn't seem sexy in that kind of way. So it's not the first thing that investors think of, like complicated, switching technology. But, of course, it has a huge, huge role to play. And, if you can get the technology right on it, then that's brilliant. Are there other people out there trying to solve this switch technology thing as well? Are you the only guys, or are there lots of people working away on it at the same time?
So that's a great question. It's really interesting because I think, first of all, the sexiness of it, when we first started trying to raise money for this over 5 and a half years ago, it was really hard because you went in and investors would look at you and go, a switch? Why do we need a switch? We have switches. And until they start understanding that what's behind this is a material science. And yes, others have tried this, and many others have tried this. But the material science behind this, basically, what what GE did was they were actually trying to source this. In sourcing it, they found out what the problem was. Is there was a reliability problems, there was electrical efficiency problems, and basically they took the metallurgists that designed the metallurgy for the fins on aircraft engines and combined them with the semiconductor device folks, and we now have a material science chemistry that allows us to make this switch. So we have a huge efficiency in how we conduct electricity, but we're also able to make this mechanical device in what would typically be a semiconductor technology. And so we can make it, as you can see, I think on this, I believe the slides are up here. You can see we can make it 99% smaller than what an electromechanical device is today because of that material science.
Mm.
So let's be clear. 40 years people have been trying to solve this problem. 40 years, and this is the first company that's actually been able to do it, and it's already in production and shipping. You know, a lot of times we're talking about these new technologies and new companies, and maybe in 4 years they'll have something, maybe in 3 years. We're actually in production right now and shipping, and it's been many years of getting here, but it feels incredible to actually to have them in production. We should actually go if we could fast forward to the slide to show people what it looks like. Yep, there's switches, lots of switches in all of these things. Switches. Let's go one there. This is what we're talking about. That's the ideal switch, the Menlo Micro one, that little tiny box, that little tiny rectangle, looks like a piece of gum, but it's smaller than that even. And a relay, that's a typical relay that are sold in the billions per year. We replaced that big old unreliable switch with something that's more or less solid state. It's a micro electromechanical system, a MEMS switch. And so that's really telling. And if we go to the next slide, which is the other form of it, if you look, there's another form of switch that's an electromechanical switch, or a silicon switch, solid state relay. But you can see all those fins on there, and you see that black thing underneath. That's all heat, because it's so inefficient that it generates so much heat that it has to push it out through a heat sink. Whereas on ours, you don't have to have any heat sinks whatsoever. So because we're so efficient, you have amazing benefits of both the relay and this solid state relay. And so this is what's so dramatically different. So think about all those big things in the world, and we can replace them with, it's kind of like moving from vacuum tubes to transistors.
Well, Tony, I mean, how did you come across this in the first place, and what made you interested? How did you sort of see through the potential unsexiness of this and think this is a really great idea?
Oh, well, that's where it all becomes really interesting. So at Nest, a company that I founded 10 years ago, or we actually did 11 years ago now, one of our biggest things, we were making a thermostat. And if you have a thermostat in your home, you probably hear it all the time. It goes click, 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 click. It's always turning on and off, depending on the time of year. And so that's a relay. It's one of those things you just saw, the picture you saw. And so there's relays throughout your house controlling your heating and cooling. Well, I hated the noise. I hated the fact that they were big and bulky, generated heat. So I was looking for another alternative that wasn't a silicon switch, a transistor. And we couldn't find anything. I said, in all of these years, we can't find something that's better. And so we ended up putting in a transistor, and then the transistor started blowing up. So you have to also understand that doing high voltage or power types of applications, silicon or transistors can blow up very easily. And so, and be destroyed in the field. So we had this problem where we couldn't use relays, we used transistors, but they were only so effective. And I looked around the world for technology, and then I found it at GE, but Menlo Micro hadn't been found yet. So I found the technology, GE wasn't doing anything with it. And then ultimately I just kept watching and watching, and a few years later, GE decided to make a company out of it called Menlo Micro, and I was the first investor. I called up Russ, I'm like, Russ. He's probably thought it was crazy. Some investors wanting to go in. I was begging him, please let me invest.
That's a nice problem.
That was a wonderful phone call. I'll tell you that, because it very seldom get somebody of Tony's stature to call you up and say, "Can I invest in your company?" Well, let me think about that. Sure.
And so it was really great to see what they were doing and how important it was. I knew what it was fundamentally because we at Future Shape we invest in over 200 companies. Like you were talking about these interesting companies that are going to help save the planet, and so we see companies all the time. And Menlo Micro is one of the standouts. And when we see these companies that we know can fix the planet, help fix the planet without making us go back in time, and stop using the things that we like to use, then we're like, this is gold. We have to help them because most investors won't help them. As you know, maybe that's going to change now. But 5 years ago, as Russ said, most investors turn a blind eye, go, too complicated. Who wants this stuff? That's the stuff we love to do.
I mean, I think one of the themes here, as I understand it, is something that is referred to as the electrification of everything. Can you explain what that is and what that means in this context?
Sure. The electrification of everything. Look, we're seeing all mobility, whether it's cars, trucks, buses, garbage trucks, whatever, they're all moving electric. We're seeing many of our other appliances around us or power generation all moving electric only. Everything's going electric, everything's going wireless as well. And when you go electric and you go wireless, that means lots of switches, even more switches than we see today. Switches are like paper clips. They're everywhere, but nobody sees them, right? We all use them, but we don't appreciate how simple yet important they are. And so as we move more and more to the electrons of everything, more and more of these switches are going to happen. So we don't want to have more inefficiencies in the system. So we add more and more power. Could you imagine? We move more and more things over from electricity or energy usage. And then all of a sudden we have to generate 2 or 3 times more power because of all the inefficiencies of this system just to power the new products that are becoming electrified. So we're going to try to make sure that those inefficiencies go away, at least a portion of them for what we can handle. And it's a lot of inefficiencies in switches.
Yeah, just to add to that, the key to this thing is we've got to make them not just small, not just efficient. We have to make them small, smart, and efficient. And all 3 of those things are really important. And that's what we bring to the party. Whether you're, you can look on this slide here. That's a circuit breaker box on the side of a building or the side of the house. When you look at how the size that you could move that to, and then as Tony said, bring 40% more efficiency to the electricity you're switching through that building, and now you also do it smartly, so you can manage it, so you control it from a computer or from your iPhone or whatever the case may be. And now you start applying that not just to homes, not just to industry and manufacturing, not just to transportation, automotives and airliners and all those things. You start seeing the plethora of applications that it fits into everything because we use switches for everything.
And we spend a lot of money on power and we throw a lot of it away. If we could actually, save that power, changing out your circuit breakers or what have you to save power. It sounds totally illogical, but it's actually the case.
We did a back of the napkin calculation on just in the US alone, there's 20 billion light sockets. If you put this switch into every one of those light sockets, you could save, and made them all smart, you could save 11 coal-fired power plants.
Wow.
When you think of that, it's kind of mind-boggling, right?
Yeah, so it could have a really big impact. I mean, it's interesting. A lot of the discussion we've been talking about making things more efficient and sort of replacing, old peaking systems that need to be modernized. But as I understand that, there's also, this technology could also make things possible in the future. Technology is about to take a giant leap forward. We've got AI, we've got 5G, we've got the Internet of Things. How is this Menlo Micro product going to create possibilities and create opportunities as well as fixing inefficiencies?
Well, in all of those things, we already are starting. So you start looking at whether it's whether it's AI and edge computing and cloud computing and data centers, for example, the amount of power that's required to digest, transmit, and operate on all of that data is enormous. You need switches, you need power plants, you need power distribution services or capabilities to be able to run those things, and adding those efficiencies to that. And the automotive side of the thing, charging, we've got to lay out complete, and that started, but there's a long ways to go. There's complete infrastructures of charging systems that need to be that need to be implemented across multiple countries, right? And so these switches will enable those devices to become better, right? I have a Tesla. If I'm driving across country and I need to charge up, I've got to sit there for an hour in order to do it, right? So how do you add efficiencies and add capabilities to allow that to be 15 minutes? Now, we don't do that by ourselves, but certainly in conjunction with battery technology and enabling that to become more efficient as well.
Sorry, my cat likes to attend these regular guest. No, that's brilliant. Sorry, just moving him. So where were we? Hang on a sec. Sorry. So in terms of the environmental impacts, I thought that was really interesting. I mean, could you say a little bit more about, you were comparing it to saving energy in terms of 11 coal plants. You know, could you calculate how it will fit in with the US goals at the moment in terms of being net zero, things like that? You know, how much of a role could this play in those government goals to cut emissions?
So I'll start off, and I'll let Tony add to this, because I know he's got a lot of color on this part of it. But if you just even what we started the conversation with, a 40% savings in distribution, in how much time is it going to take for all of the renewable sources of energy to, and as we said at the beginning, not that we don't need to do those things, but they're going to take a long time in putting those infrastructures in place. This switch can be retrofitted into various applications across the distribution network of power, and so you get the payback of that 40% gain much quicker than changing the source of energy. And I think that's the really big application, and we're already seeing it just in a different way in communications, as we start applying this to 5G and more efficient communications, and how bandwidth can be improved with this kind of switch, which also relates all the way back to energy. But the distribution capability, I think, is going to be the first big impact.
I agree with you, Russ. And if you look at 5G, we're going to put on this planet 5 to 10 times more cell towers than we do today. We're going to put in order of magnitude more cell towers. Those are already, the ones that are installed are highly inefficient from a power perspective on the RF side. You drop in ours, you know, as you can see in the slide again, you save that 40% power right there, and you get better actually reception. You may be able to actually put less cell towers out there. So just think about that infrastructure alone that's going up, and how inefficient it was going to be, and now how efficient it can be. And to Russ's point, this can be retrofitted into so many things, so we don't have to go through all of the CO2 production, everything else, to make new planes, make new cars. We can retrofit this into houses, into cars, into planes, what have you, to get these inefficiencies right away. Wouldn't you like to have, you know, a 20% better, you know, battery in your car without having to buy more battery or tear up more land, you know, for lithium mining or cobalt mining or what have you? This is, you know, this is a very opposite way, different way of thinking about attacking the problem. And what's so great is you don't have to have all new products to take advantage of it. You can drop it into the existing ones. And it's amazing, the size and cost and reductions as well, not just the power savings.